This is part 2 of homework 6. I'll probably do this in 3 videos. We're going to talk about definition of a relation. It's a set of ordered pairs x and y is called a relation in x and y. Definition of a function. Given a relation in x and y, we say that y is a function of x if for each value of x in the domain there is exactly one value of y in the range. That means one x goes to exactly one y. We can do this by, if they give us a graph, a vertical line test. A graph defines y as a function of x if no vertical line intersects the graph in more than one point. Okay, so basically what the graph says, if you can, or by looking at a graph, if you do the vertical line test, you can put a vertical line anywhere along on this circle, just a line going up and down. If it touches at 2 points, then it is not a function. It touches here and it touches here, so it is not a function. Right here, I don't care where I draw my vertical line, it only touches at one spot. I cannot draw a vertical line and it touch at more than one spot. Okay, so this says it is a function. Now right here, those are 2 points that are filled in, okay? That means it's counted here and it's counted here. If I draw my vertical line right there on the y-axis, it touches at 2 points. It touches here, because that's a filled in circle, and it touches here, so it is not a function. Now, that graph, it could look something like this. Let's put an open circle here, and let's say it goes like this, all right? And then we have a closed circle right here, and it might go something like this. The difference between these two is this filled in circle. It was a filled in circle here, so it counts, and it was a filled in circle right here, so it counts. So it counts at both of those positions, so that's why it's not a function. Here, if I draw a line, it doesn't count here, so it's only hitting at one spot. So this is a function, where this one's not. Okay, right here, one x can only go to one y. So on this particular case, our x value, our domain, or x value, we only have 2. That's our, no, we have 2 and 3. Oops, sorry. And we have the y values of 3, 4, and 5. Okay? So we have a 2 going to 3, and we have a 2 going to 4. That automatically says it's not a function. I'm just going to put yes and no from here on out. Okay? This 3 actually goes to 5, so it is fine. It's just this 1, 2 can only go to one of these numbers, not 2 of them. So right here, we have our x values of 1, 2, and 3. And our y values are 3 and 5. Okay, so we have 1 going to 3. We have 2 going to 3, and we have 3 going to 5. This is a function because it doesn't matter that we have 2 x's going to a y. See the difference here? This is 1 is only going to 3. 2 is only going to 3. These x values only go to one y. This x value went to 2 y's, and that's why. It's similar to me. let's say, or any teacher, okay, let's just use me as an example. For it to be a function, some of the instructors, let's just say, or a teacher, okay, might get paid $45,000. Others might be paid $50,000. Okay, some are paid $60,000. They're all different. Okay, this would be, let's say we have Kim and we have, let's say, Tom. Okay, let's say Kim gets $45,000, Tom gets paid $50,000. This is a function. Okay, this one is, but they wouldn't allow me to have a $45,000 salary and a $60,000 salary. This is not a function, okay? Because they would not pay me two different salaries for the one job. Okay, so back over here, these are only going to one thing over here. So this is a function. I'm just going to put yes and no at this point. Right here, I'm going to, you can actually graph this, okay? And it would look like it would be up here. It would look something like this. It would be a line. It's linear. I know that because it has an X. This is a function. I can't do the vertical line test. Now you can graph these points also, and you'd find out they weren't a function. Right here, if you were to graph this on your calculator, okay? Where's my calculator? Okay, go to y equals and type in 2x squared plus 6 and graph it. Okay, let me go up a little bit higher on my y so you can really see what this looks like. Okay, I can draw a vertical line and it only crosses at one point. So this is a function. So again, this was going to look something like this. This is a terrible graph here. It's kind of crooked, sorry. Okay, so yes, this is a function. The thing you want to look for is an x squared. I'm sorry, a y squared. Once you see a y squared, it's not a function. Okay, this one right here, if you were to look at that, if you were to put it in the form of y equals, it would be y equals negative x plus 7. Okay, so that would look like this if you graph that on your calculator. So it does pass the vertical line test, so it's yes. This one here, okay, I'm going to take this y squared over to the other side. It becomes positive. I'm going to take the x over here. It's become negative. So if I added y squared to both sides, I'd get this. If I subtracted x from both sides, I'd get this. Now, to solve for y, I would have to take the square root. Because I put in that square root, that is when we take the positive and the negative square root of negative x plus 7. Because of this positive and negative, that is why no, it's not a function. If you were to, I don't know how this is going to look, but if I'd have to graph this in two different, one under y1 and one under y2. This first one would be second square root of negative x plus 7. And then the second one would be the negative of that. Oops, I was going to see if I could just copy it, but I can't. Okay, so it's the same thing, just one has a positive on the outside, one has a negative. I have no idea what this graph's going to look like. Okay, I thought so, but I wasn't quite sure. Okay, so this graph here looks like this. And it does not pass the vertical line test, okay? But I know that because of this right here. This right here, however, this has to be even, okay? This one's fine, all right? So I'm going to take this over to the other side by adding it. So I'm going to get y cubed. I'm going to subtract the x, so I'm going to get negative x plus 7. Then I am going to take the cube root. Because you're taking the cube root, you don't do a positive and negative. You just do the cube root of negative x plus 1. So yes, this is a function. Because it's not going to have that plus minus. I think we can, let's see what this looks like, because I don't have my notes at all. I don't know what it looks like. Let's go to math. Cube root is 4. Let me put it up here so you can see it better. Where there's no glare. And it was negative x, oops, I put plus 1, that is plus 7, so you're not here to correct me. Plus 7. If I hit graph, yeah, it's going to look like that. Okay, so, and I can make this actually go back to the way it was, 10. And I can make this go from, let's say, negative 10 to, let's say, 30, just so you can see what the graph looks like, what it looks like. See, it'll pass the vertical line test. Okay? So it looks like this. So again,